So in this video, we're going to be talking about higher order derivatives. So far in the class, we've only been talking about what are called first derivatives, or just taking one derivative of a function. But it turns out you can take as many derivatives as you want in succession. So for example, if you took a derivative of a derivative, that would be a second derivative. The derivative of a derivative of a derivative would be the third derivative, and you can just keep on going out. Some functions have an infinite amount of derivatives. Some have a certain amount of derivatives until they just hit zero. But when we describe derivatives, there's a couple ways we can do that. So notice that in the language, when we describe a second derivative, we have two primes. So instead of a first derivative, which looked like f prime of x, we now have a second derivative that again has those two primes in there. In a third derivative, we have three primes. Another way we describe derivatives was saying dy over dx, which really that's the same as saying d to the 1y over d times x to the 1. When we look at second derivatives, we just have a squared up in there, okay? When we do third derivatives, we have a cube, and then these are just two other ways you can describe higher order derivatives. So really they're used in the same kind of language as regular derivatives are, though when you have like d2y over dx squared, when you put those exponents in there, sometimes that can tend to confuse students, but that basically just means a second derivative. All right, so let's look at an example of calculating several derivatives. So we want to find the first, second, third, and fourth derivatives of this function 3x cubed minus 2x squared plus 4. So see if you can do that on your own real quick. Pause the video, and then let's see if you got it right. Okay, if you did this, again, using our power rule that we know, you should get that the first derivative will be 9x squared minus 4x. The second derivative will be 18x minus 4. The third derivative will just be 18. And then finally, the fourth derivative, which once you get up to 4 derivatives, you start putting Roman numerals in for up here, because you're not going to put in a huge amount of slashes as they go on forever. So that would just be 0. Okay, so this is an example of a function that in this case it really only has 4 derivatives, because after the fourth derivative, if we did the fifth derivative, the sixth derivative, the seventh derivative, we would just get 0 every single time, so they're not interesting. But when we look at other functions, like for example sine of x, you could take the derivative of this function as many times as you wanted to, and you would keep getting something. Now it turns out after 4 derivatives, you would get a certain pattern that arises, and that pattern would then repeat. But you could still take as many derivatives of the sine function as you wanted to. So come tomorrow to class with questions, and we will start the next video soon talking about what first and derivatives can tell us about graphs of functions.